This is Steve Wright for YUV Soft with a tutorial on the use of depth propagation for foreground objects. In the previous video, we saw depth propagation is very effective on the background areas of a scene, and it was mentioned that it could also be used for foreground objects in situations where there's limited movement. In this video, we'll take a look at the workflow for using depth propagation for foreground objects. We'll be using this clip to demonstrate creating depth maps for the man in the foreground using just 3 painted keyframes and an overall isolation roto. But first, let's quickly review how this would be done using the traditional manual approach. The manual approach for high-quality stereo conversion is to create roto masks for each important part of an object, then assign it a depth level as either a solid color or a gradient. These various masks must then be composited together in the right layering order to produce the final depth map. In the case of this head, 6 masks were required. Depth maps for the body are also required, of course, each one manually rotoscoped, color graded, animated, and composited. Altogether, this example required a total of 16 masks, and having to composite them introduces the possibility of compositing errors and unnatural depth drops at the border of different masks. The disadvantages of the manual approach are that it's labor-intensive, so it's expensive, and it's time-consuming, resulting in long schedules. Also, when objects move in depth, it requires their depth map colors and gradients be manually adjusted over time. Since it's not uncommon for there to be 200 plus layers in a shot, it's also a terribly error-prone process, with masks assigned an incorrect depth level, placed in the wrong layering order, or forgotten completely. Using depth propagation for foreground objects can offer a dramatic reduction in cost and time without noticeably affecting quality. Next, we'll see how it's done. The depth propagation approach for foreground objects simplifies and speeds up the process of conversion. Detailed depth maps are only needed for a few keyframes, along with just 1 isolation roto for the foreground object. Only 3 keyframes were painted for this shot, then detailed depth maps were propagated for the entire shot. Here's the workflow. Step 1 is to manually paint detailed depth maps for just the keyframes you need. In this shot, only 3 keyframes were needed. Step 2 is depth propagation. Using depth propagation over the entire frame is not suitable because there would be depth leakage between the foreground and background objects. We saw examples of depth leakage in the previous video. Depth leakage is undesirable because it loses small details on object boundaries. Now here's a painted keyframe over black as you might produce with Adobe Photoshop or other paint tool. However, with black surrounding the foreground depth map, the background regions would leak into the foreground. To prevent this, the surrounding area needs to be filled with a depth level that correlates with the depth level of the object's boundary. This prevents the background from leaking into the foreground. So a correctly filled foreground keyframe would look like this, the black area filled with the depth level matching the foreground object's boundary. If we check the propagated foreground depth map at frame 20, you can see there's depth leakage from the foreground into the background. But this will be easy to fix using the foreground isolation roto. Because the original keyframe depth map was filled with the proper depth level, there was no leakage from the background into the foreground. Step 3 is to composite the final depth map by combining the separately generated foreground and background depth maps. It's a simple matter now to use the foreground isolation roto to trim the propagated foreground depth map and composite it over the propagated background depth map, preserving all the fine detail on every frame automatically. This composite was demonstrated using Nuke, but of course you can also use After Effects. Here we can see the final stereo shot produced by the stereo generator node. The advantages of the depth propagation approach for foreground objects are less manual painting. You only need 1 isolation roto for the foreground object and to paint just a few keyframes. Less compositing work. There are far fewer layers to composite, so there are far fewer opportunities for compositing errors. You get faster conversion with comparable quality if, again, the foreground object motion is not too extreme. While depth propagation for foreground objects is not a replacement for the manual approach in all cases, it can save both time and money for many shots without sacrificing quality.